Thank you, Brian, and welcome everybody. I'm Russell Dupuy, Head of Innovation at Environmental Monitoring Solutions. Joining me here is Zoran Angelovski, Senior IoT Consultant at DiUS. Zoran's going to talk to you in a few moments, so I'll get going. I founded EMS in 2003 with a small group of scientists and engineers that grew over time to a much larger group of passionate professionals sharing a common vision, protecting our environment. Our purpose is simply driving fuel intelligence, which means converging science and technology to help our clients reduce their environmental impact, whilst driving significant operational improvements that maximise their profits. What I'm going to share with you is three significant problems faced by all petroleum retailers that we solve. I'll then talk to you about the challenge my business faced moving from old technology to new technology that we believe will be a game changer for our business and our clients alike, built on the AWS platform and developed by DiUS. Zoran will take the baton.
Thanks, Russell. So I'll be talking about Fuelsuite, the solution, and also what's underneath Fuelsuite. But I'll also talk to the architecture and in an effort to give you some insight into why we've chosen certain services and how we've gone about implementing the IoT solution, but more importantly, Fuelsuite. Thanks, Russell.
Thank you, Zoran. Okay, I'd like to tell you a little bit about what our client looks like. As I mentioned, we're an Australian-founded business. We provide services, analytical services, to approximately 4,000 service stations in Australia, New Zealand, and Canada. Our typical client will operate between 1 and up to 800 retail service stations. They'll sell up to 3 billion litres individually of fuel a year. They will spend up to and sometimes greater than $15 million a year dealing with environmental cleanups. They can also spend up to $45 million a year maintaining their retail asset where we all go to get our petrol. Our service goals are to reduce our clients' environmental cost by greater than 50%, reduce their maintenance budget by better than 15%, and reduce their fuel variances by greater than 0.2%. So as you can see, these are very big numbers, and you can probably imagine that having visited probably many service stations, there's a blended of technologies, often high tech to low tech and everything in between. Our job is simply to knit this together in a way that our clients can digest that voluminous data and make informed decisions. Before I go further and share with you the three problems we solve, I must qualify the two videos I'm about to show you are for illustrative purposes only. I'll only talk to them generally and not specifically. I'll draw your attention to the attendant on the your left-hand side of the screen and the ute approaching at the back of the forecourt. I bet that got your attention. As you can see, a few words ensued. So what was really going on here? He was performing a task that's performed every day at a service station. Last year alone, 12 attendants were hit by a moving vehicle doing this task, which often results in broken bones and or crushing injuries. The task he was performing was simply dipping the underground tanks to determine what the volume was, to reconcile their fuel, and then arrange for replenishment fuel. And this is what they do each day. They go out to the forecourt and hopefully use more bollards than what this gentleman did, usually 3. They will then bend down on the forecourt, uncover a lid, unscrew a cap, at which time they're inundated with saturated vapour, petrol fumes. They reach in and take a dipstick out. It's a yardstick at best. The increments of volume between 300 and 500 litres. They pop it back in, write that down, screw it back on, pop back up, and go on to the next and the next and the next tank. So if I scale it up for you, there's reportedly 7,000 service stations in Australia. On average, they have 5 tanks. So this task is performed daily 35,000 times. Or think of it like this, 7,000 people put their self at risk 5 times a day performing this task. More recently, operators or attendants have been assaulted performing this task on the forecourt. How do we solve this problem? We solve this problem 2 ways. We have a technology solution that goes into the tank that measures the inventory accurately, provides a console on the wall, and we can connect that to their enterprise for real-time data. That's usually for the top end of town. For the rest of the market, it's usually a fairly big investment they can't afford. How we help them is with the obvious OH&S matters that you just saw here, but also through our data analytics, we remove the lumps and the bumps out of the data, so their reconciliation data that they rely on for upstream decision making becomes reliable. As you can imagine, there'd be a different operator every day on every site, and in fact, I'm sure many people here have actually performed this task. The next video I'm showing here was filmed by Joe Citizen in 2009. It made every major newspaper, radio and television station. It's pretty evident there's a fire on site. There we go, I bet that got your attention also. That's an inferno. So what happened here? Well, to have a fire we need three things present: saturated vapour, oxygen and a source of ignition. As I said, I won't talk to it specifically because I'm not at liberty to do so. Basically what happened here is the tanker that was arriving on site, that BW that you can see that's on fire, had a load of petroleum product that could not fit in the tanks underground. What's happened is, through the process of decoupling the hoses, there's probably been about a 40-litre spill on site. There was a source of ignition, which we believe was the hot surface of the exhaust pipe, and then you can see the rest for yourself. Now, if it wasn't for the efforts of the fire brigade cooling the right-hand side of that tanker, 10 more compartments would have gone up. So you can imagine the inferno that would have ensued. They believe a radius of 200 metres would have been scorched. How do we help our clients solve that problem? Well, if you think about the last video we showed you, relying on that guy running out, guessing what's in the tanks, you can see how this problem can occur. We help them by providing real-time information to the guy on the truck, so when he gets to site, every 30 seconds he can push a button and know that what he's got on board will either fit or not fit, so he can make a decision on what he does next. The next problem I'm going to describe to you is that of leaking tanks. We call it the silent thief. As you can imagine, every service station has tanks underground, on average 5. They store somewhere in the order of 150,000 litres of flammable products. If they're leaking, they leak silently all the time, continuously. Here's an example of a leak that made its way to the stormwater, that made its way to the beach in a place called Balgee in Victoria. It was a fairly significant contamination. An investigation ensued, and it was found that this service station, quite a few hundred metres away, was the root cause of the contamination. The operator was compliant, they were doing the right thing, but they were relying on data that was a month old to detect the leaks in their tank. So what simply happened is the plume underground got to such a point, it hit groundwater, migrated off-site to surface water, found the stormwater, and there was a major contamination. Reputational damage and obviously significant cost. This is one of my favourites. I worked on this site. This was another contamination in Victoria a few years ago. How this was discovered was by an apprentice on his break having his cigarette, literally in a park, and went to take his last puff and flick the cigarette into some surface water, thinking it would extinguish. He had a flash fire and had superficial burns. The EPA work cover got involved, and they found this root cause was a service station you're looking at. Again, they complied, they were doing the right thing. The leak was under the detectable threshold. We often hear that this is not a real problem. People say to me, does it really happen? Well, let me tell you, it does happen. In 1984, 60 Minutes ran a documentary in the US on a town called Richmond in Rhode Island. What had happened is a local service station had a major failure underground, and 50,000 litres of petroleum product found its way to the only drinking source for that town. Reagan at the time simply said that's not good enough, and in 1988 mandated a protocol that the EPA monitored for a 10-year period. This is what they found. Over that 10 years from 1988 to 1998, they closed 1.5 million tanks. Over 380,000 sites were cleaned up at a run rate of 19,000 a year. At conclusion of that, there was 130,000 sites left to clean up. It is a big problem. Closer to home, most EPAs in Australia have a similar compliance program, and we help our clients with that. New South Wales EPA were brave enough to quote that 900 sites they believe were leaking in New South Wales as of 2012. It only takes about 300 to 400 litres of petrol, diesel or crude oil to contaminate 1 million litres of drinking water. So for places like Canberra and Perth, this is a significant problem. Through our analytical services, We help our clients solve this problem by removing the anomalies and the lies in the data so we can establish a benchmark to determine if their losses or gains are acceptable or not and whether action needs to be taken. I'll now talk to what brought us here today, our problem. We wanted to move from near-time, month-old data, week-old data to real-time. Now to do that, we had to develop some technology that wasn't available. We had to develop a device, a custom piece of electronics that would deploy to a service station and connect to a range of things so we could monitor a range of sensory inputs. We then wanted to connect it to the cloud to have real-time information in a secure environment. We have old web technology. We wanted to move to the real world, the new world, and we had to think about a new cloud platform. We had to migrate our existing technology from our old to our new platform, which was a pretty big lift. We then had to choose a partner to hold our hand and take us through this process. Whilst we're scientists and engineers, we're not IT specialists. So we had to find a partner to do that with. We then needed somebody to help us with what cloud platform to use. Again, this is not our core competency. I'm delighted to say that we chose DiUS as our chosen partner. It's very comforting as a business owner when I'm spending millions of dollars developing my next frontier technology that will be the springboard for our global growth, that we've got a company that thinks the way we do, that can work with us in step to deliver what we want. They also held our hand and helped us understand the whole AWS IoT cloud platform that I won't pretend to understand today, but the commercial decisions they helped us make were significant. That's at this point I'd like to introduce Zoran, who's going to talk to you about our next generation Fuelsuite.
Thanks, Russell. Cheers, mate.
Thank you.
Thank you. So I'd like to give you a little bit more insight into what we've done for EMS with regards to Fuelsuite. Now, before I do that, I'd like to give you just a little bit of context of what DiUS does and why we're best placed to deliver Fuelsuite TMS. Fundamentally, we're really about delivering digital transformation projects, and we've been doing that for a very long time. Our capabilities span from user research and ideation. We have a large group of developers, but we also have our own data scientists that work on those next generation analytics where we solve problems in the data domain, essentially. Now, we have been partners of AWS since 2010. We were awarded Consulting Partner of the Year in 2016, and today I learnt that we were awarded Innovation Partner for 2017, something we're rather proud of. Now, coupled with all of that, we have a pedigree in delivering connected devices. So we connect the digital to the physical. And I've shown a few of those devices up there at the moment, and I'll briefly mention ChargeIQ. ChargeIQ was an electric vehicle charging terminal. It's actually a connected device. We developed that back in 2009. And in fact, we developed our own data platform behind it. So we have a good sense of what it takes to develop our own data platform, but also the leverage we get when we go to a platform like the AWS system and the efficiencies we get out of that. Okay, moving on to the solution. I'd like to say a few words, a little bit about the existing technology. So Russell went through and spoke to the problems and also touched on the age of some of the equipment that we're dealing with. Now, when I talk IoT quite often to many people, a lot of the times it's about a shiny new device, something that does something really cool. Well, this project is not that. It's very much unlike that. It's about those real world problems, the ones that impact the environment, the ones that impact health and safety. I mean, a lot of the substances here that we're dealing with are flammable, but they're also toxic. So, what I've got up on the screen there is a favourite image of ours back in the office. And this kind of hit home with one of our very first visits on site. In fact, we installed our first equipment here and had it connected to AWS. It shows a tank gauge, and the mechanism used to convey an alarm on that tank gauge was actually a paper label above the device itself. So this is how the station's attendants knew that there was an L3 alarm and not to worry about it because it had a faulty sensor. This was really the simple use case, which was one of our first experiences that we knew that we were going to significantly improve. Okay, the core business, or the traditional core business of a petrol station, has really been about the fuel. So it's the tanks, the pumps, and the price board. And on many occasions, this is serviced by old hardware. and it uses old protocols, all working, but nonetheless quite old. Communications is often through what we call a current loop communications, and a lot of the pumps are actually connected in that way. Now, although this has evolved over a long period of time, it is standards compliant, well, mostly, except for the fact when we've had to deal with proprietary protocols that have had to be reverse engineered, but also this sort of thing. So this is a digital data stream of one of the current loops we came across. Now, it should be a fairly smooth digital stream representing the ones and zeros, but as you can see, it is anything but compliant. There's that significant spike at some of the transitions. Now, this is well and truly out of specification. Now, a little bit of trivia before I leave this page. The current loop has been around for a while. In fact, it was on a common device. Now, it does span back quite some time. It was on this thing. That's the first ever PC. It's the IBM 5150 from 1981. It had a current loop data port. I couldn't believe that. Okay, so this project is very much about real world problems, and also that underlying commercial reality where we're not going to be able to swap out equipment en masse, where we can move to something that gives us that really convenient modern API. It is not that. Okay, what's the task? What is it that we're actually trying to achieve? Well, obviously it's about the petrol station. It's about connecting on-site data in a scalable and cost-effective manner. And we'd like to do that in real time, or near enough real time for our purposes. So we start off with the tanks. Now, the tank gauges actually give us a lot of information. In addition to the levels, we can detect water. We can also get a temperature reading. We would also like to connect to the pumps. So they actually tell us what's being dispensed. So you can see here that when fuel is delivered, we know how much is in the tank. We now, that is in the truck, we now know how much is in the tank underground, and we now know how much is actually coming out. We can close the loop. So you can imagine how then we could determine quite a bit of information from this data. Now, the last thing that we're connecting is the price board. Now, that's not such a critical problem for your regular metropolitan station. You know, a attendant can simply go out, they get a remote control and set the price. But it is more critical when we're dealing with remote unmanned sites that are 100 kilometres away, and it would be really good to be able to do that remotely. So essentially this is about building that capability to provide insights in order to anticipate problems before they occur. So we'd like to be able to get an insight into these issues before they occur and stop them before they actually happen. So I'll bring you back to the good old truck driver that we had earlier on, and now his job was made really, really difficult. He relied on the dipstick that wasn't accurate. So we can now improve that. So this is a very simple use case where we can take some simple measures, but we significantly improve the outcome of how he does his job. Okay, so how do we bring the value to the business? Well, many problems at the moment, they're actually solved in a reactionary manner. So if you have water contamination and you're unfortunate and your vehicle is damaged, it can actually take up to 3 months before the data is sifted through and the details of what actually happened are determined. Well, we'd like to move away from that. We'd like to have the data available, analyse the data, do that in real time, and then use our capabilities in the predictive analytics to avoid an incident occurring. So you can imagine under the old model how long it would take to detect a subtle fuel leak. I mean, it could actually be years before it's detected. Okay, what is the Fuelsuite solution? I mean, what does it comprise of? Well, of course, there's a petrol station, and we'd like to connect data over a mobile data network. And we need to get that data into a consumer. In this case, Fuelsuite is our consumer. That's where we actually bring out the data that's important. We visualize it, we pick out the parts that are important, and we get that data to the people that can make a difference. So if there's water in a tank, we can get it to the person that can actually turn off the dispenser that's attached to that tank. Now, what's underneath all of this? Well, as we've seen, we had the tank gauge from earlier on. We also have a device that's essentially a single board computer module. It provides us with the LTE connectivity, and we're using 3G and 4G at the moment. But attached to all of that is our pump communications module. Now, this is the custom hardware that we've built to talk to the pumps over that current loop communications. And it operates in two ways. One of the requirements from Russell, from EMS, when we developed this, is that it needed to be non-intrusive on the current loop. So we developed methods that were completely electrically isolated. So the last image that I've got on there is actually simply the internal circuit board of that device. So this is the custom piece of hardware that we developed. Now all of this equipment, essentially it forms, or they form, the things in our Internet of Things. And they all attach over a mobile data network into the AWS cloud infrastructure. So what does this actually look like at an architectural level? Well, as we just spoke then, the things are all those devices, the hardware that we have at one end. Now, when we deploy this solution, we'll actually have thousands of these devices, and they all need to communicate effectively over a connection. So that's where we leverage AWS. We need to get the data into the cloud where we present it to Fuelsuite, where it can be consumed. But importantly, there's another aspect to this. We're deploying thousands of pieces of equipment. We need a way to manage that. We need to be able to operate, administer, provision and maintain that equipment. And if we can't do it effectively, we actually will find it very difficult to deliver this service. That's the other piece that AWS gives us. So what are the details behind this? Well, at one end, we've got the fuel tanks, the pumps and the price board. We need an IoT connection, and AWS gives us this. So at one end, we have the IoT SDK, and we can tap into the software development kit and its capabilities. So it provides a connection from the remote end all the way through to the cloud, the gateway or the hub, both common terms for this. And underneath that, we get that connection. But leveraging AWS, we get a secure end-to-end connection. In fact, we also have a mechanism to authenticate devices, and we can tap into the certificates that are generated by AWS for us to do that. In addition to that, we actually need a protocol, and we've chosen MQTT. Now, we like MQTT for two reasons. The first one is that it'll operate over bandwidth-restricted environments. That's important. Today, we're using 3G or 4G, which is relatively high bandwidth. But in the future, we'd like to leverage narrowband IoT technologies. So this effectively gives us a level of future-proofing. The other reason we like MQTT is because essentially it's a light protocol. So when we deploy our thousands of devices, there will be an equivalent number of SIM cards. So it'll be much easier on our data plans, and it won't cost us as much, essentially. So, where do we get this? Well, it's all existing capabilities in the AWS platform, existing libraries in the SDK, and an existing gateway or hub at the cloud end. So now we have our connection. We can actually get our data into the cloud, but we need to be able to do something with that. And if you recall, I said we need to consume data, but we also need to be able to manage the equipment that's attached to that. So in comes the rules engine. So this is where we begin to consume our data. Now, we like the rules engine because it's very easy to actually route the data that's coming in. So we can set up simple data routing and get it to the AWS service that we need to consume it. It also offers us a level of demarcation between what's happening in the cloud, but also the device. So we can actually easily adjust that routing. So if AWS bring out a new service, we can make a simple change in the cloud. If EMS come to us and say, look, we really need this new function, and we need to rely on another AWS service, we do it in the cloud. But fundamentally what that gives us is that we don't touch the other end. We don't need to rely on a firmware upgrade. And we really want to avoid that because there's thousands of those that are geographically dispersed. Okay, so that gets us to the next point where we consume the data. This next part is really about how we manage those thousands of devices in the field, and this is where we leverage the device shadow. It's a very simple way to see whether the device is online or offline, but it also gives us a requested configuration versus a reported configuration. And if there's a difference, we can simply reconcile that and the devices go away and do their job. It'll also work with intermittent connectivity, and that's critical because we're operating over a wireless network. And the other feature that it gives us is that we can actually pre-configure the cloud with all of the devices without having them installed in the field. So the installers can go about, do their job, and as devices are installed, they'll come up and essentially start working. So this is up to the IoT connection in terms of the IoT capabilities that was leveraged from AWS. Beyond that, we tap into the many other AWS services. Now, I can't go through all of them because there's so many. So I'll just mention a few of them briefly. The Kinesis stream. Now, we use the Kinesis stream so that if you can imagine, we have all of these many thousands of devices that are out there. They're all funneling data into this concentrated point. So we need something with the bandwidth, with the data throughput that can actually handle that. And the Kinesis stream simply provides that. It has the capability. It's at that big pipe that we need. Firehose is another service. Firehose actually lets us use streaming data, and it allows us to get that data to where it also needs to be used within the AWS system. Elasticsearch is another feature that we tap into. It allows us to use index data. Now, fundamentally what that allows us to do is narrow down on a site somewhere, anywhere really, it can be Western Sydney, New South Wales, Queensland, and we can actually narrow down to site-specific information so we can delve deeply into what's happening at that site. And there's also the notification queue. If you can imagine, through this system we'll have alarms, there'll be events, and they'll have a priority and an urgency associated with them. So we need to get them to the person that can actually make a difference. And the notification queue allows us to do that. So these are just some of the services, as I said. But what I'd like to leave you with from this particular slide is all of this is available. So it's all within the AWS cloud we leverage. So what that allows us to do essentially is use the services we need, architect them, bolt them together, and then we can focus on the custom bits. At the remote end, the hardware that we need to develop or the firmware. And at the other end, we can actually focus where the business value is realized in Fuelsuite. So it enables us to do that. Okay, where to next? Well, we've been testing, doing a lot of testing, we've been field trialing and so forth, proving the solution. We will be operational at 1,000 sites. Now, I don't want to understate this point actually. If you can imagine, at the moment, across the industry, there's about 20% of tanks that are connected. They upload data once a day, and we don't have any pump data at the moment. But what we will do is when we deploy to those 1,000 sites, all tanks will be connected, all pumps will be connected, and we'll get data every 30 seconds. Now that's a monumental shift in data. It's actually a significant change for the industry and a game changer in terms of EMS delivering services to this industry. So what does that give us? What does that do for us? Well, it actually allows us to realize that change or that move from being reactive to proactive. It realizes the reaction to anticipation model where we get the business value, and that's where we get the gains in the environmental consequences or the maintenance side of things. So we can actually look for pumps that are under dispensing or over dispensing and allocate our maintenance program according to that. And there's also those occupational health and safety issues that we saw that were quite striking earlier on, and let alone, I guess, all the dollars that are associated with that. Now beyond that, we will investigate further. We'll leverage our data analytics and our next generation analytics capabilities and better target our environmental testing. So can we, from the data, determine which sites to monitor more frequently, to take our resources and allocate them where they are actually needed. Now this has mostly been about fuel at petrol outlets, but fuel stations have become an entire retail operation these days. So the next thing we will investigate is, do we instrument other appliances out in the field? Is there a business case to instrument the refrigeration system so that the food doesn't spoil? And finally, I'd like to bring you back to our truck driver that's delivering fuel. He now has real-time, up-to-date information to use. He can actually receive a notification from head office to find out what the latest fuel levels are and do his job with confidence, but most of all, do it safely. Now that finishes our presentation. We do have a booth here. If you'd like to talk to us in more detail, do please come and visit. Both Russell and I will be on the booth. Thank you, Russell. Thanks for your help. Also a big thanks to AWS. I mean, this is really a fantastic forum. We can exchange these sorts of projects and what we're doing.
Thank you all for attending. We look forward to meeting you at the booth.
And if you'd like to reach out to us, please get in touch. These are our contact details. Thank you.
Thank you very much, guys. That was excellent. We really appreciate it. So I think it's great, and you guys will all agree that we're getting industries like this really leveraging the cloud. We're used to hearing about the Airbnbs and the Ubers, but to get the petroleum industries and the banking industries, it's really awesome. And we're really lucky to have companies like DiUS helping these folks get to the cloud. I didn't mention it before, but DiUS is 2 years in a row Partner of the Year with AWS, so please do find time to jump over to their booth, as they said. You can talk to both Zoran and Russell about what they've done and how they've done it and how they can maybe help you do it. Just out the door to the right, they're not far at all, and they would love to hear from you. So thank you guys again for coming. We'll see you